Quadratics, the quadratic formula. To find the solution to ax squared plus bx plus c equals 0, we can use x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. It's worth remembering this formula because when you get to situations where you can't easily factorise it, it will always tell you the solutions. Another method we've got is completing the square. For completing the square, it's easier to look at an example. So we'll look at the example of x squared plus 6x plus 11. For completing the square, what it means is get rid of that linear x term in the middle. To do that, we can half the coefficient of it. So half of the 6 is the 3. So we get x plus 3 all in brackets squared. What we then have to do is we have to take away that 3 squared, because if we expanded out that bracket, we'd end up with the 9. So half of the 6 and then the 3 squared is 9. We have to take that away. We always take it away. And you've got your constant on the end, your plus 11. So half the coefficient of the x in brackets squared, take away that number squared, and then add on your constant at the end, simplify. We just simplify this up, x plus 3 squared plus 2. We'll see another example here. By completing the square, find the coordinates of the turning point of y equals x squared plus 6x plus 11. Completing the square, it was the example we've just seen. Half the 6, we get the 3. Take away the 9, add on the 11, gives us plus 2. How does that tell us the coordinates of the turning point? Well, what it is just a translation in the x-axis and a translation in the y direction. We know it's a minimum point because it's a happy quadratic, it's got a bottom. The minimum point is going to be the solution of the bracket, so that's the minus 3, and the constant on the end, so that's the 2. So we end up with a minimum point, minus 3, 2. Another example, express fx equals 2x squared minus 12x plus 7 in the form a brackets x minus b squared plus c. So that's saying put it into completed square form. The only catch here is that there's not just a single x squared. So to get that, we have to pull it out. I find it easier just to pull it out the terms with the x's in. So you get 2, and I use square brackets here, x squared minus 6x. Then all I'm going to do is complete the square on what I've got left. So x squared minus 6x turns into x minus 3 in the brackets squared. I then have to take away minus 3 squared, remembering that that's going to be plus 9. I take away 9. Expanding this out, we get 2x minus 3 all squared minus 18 plus 7, which is 2x minus 3 squared minus 11. Another example, f of x equals minus x squared minus 2x plus 7. We're going to put that into completed square form. It's the same as the last one, it's just we realise that the coefficient of x squared is minus 1. So we can pull out a minus 1, or it's a little bit neater just to pull out the negative sign. So we end up with minus square bracket. Minus, in the bracket, half of the 2 is the 1. The 1 squared is 1. So we end up with that. When we expand out the bracket, we get minus x plus 1 all squared plus 1 plus 7, which is minus x plus 1 squared plus 8. If we wanted to sketch this, we know that it's got a maximum because it's a negative a, so it's a sad quadratic. And we know it's the solution of the brackets, that's minus 1. And we know we've got the 8 as the y value. We know the crossing point of the quadratic is going to be 7. The line of symmetry is the x line that goes through the x coordinate. So that's just got the form x equals minus 1. Thank you.